So the next step is that we're gonna take the projected base curve. We're gonna work with this guy now, because this one, we're gonna give it a thickness. And so on both sides, so basically we're gonna create the offset of this curve simply on both sides. So how are we gonna do that? First, let's flatten the curve. And then let's join the curve. Yeah, that gives us two curves, correct? Then I want to take the midpoint to sort them on height. I want to have this to be my first curve and this to be my second curve. Let's deconstruct this. Let's take the sets and sort amongst the sets and also with the joint curve. Yes, because this is basically our starting curve. We can also call it as such. Yeah. Let's hide maybe this. We need a bit more space now, so let's all do this. Okay, so this one now, we want to generate points on the curve. So we're gonna explode this one. This creates like 7 different ones. Yes, and we're gonna do divide curve. No, yeah, divide curve. The amount of points we want to, that's why we have the spare meter. So we have divide distance. It's at the moment it's standing on 3. So let's take the length of each of these ones and we're gonna divide it amongst 3. We need to work with whole numbers, so simply just put an integer behind this and this create whole numbers. Actually, just to show you, because we don't want this kind of numbers, we want these kind of numbers. Yeah. Okay, and then we're gonna divide it perfectly. We can see that we have divided quite nicely at the moment. But let's flatten this out. So it is these 132 curves. Oh no. Now we want to keep the structure of the two curves. So here we're going to use a shift path again. So we're going to create from all the different branches. We want to go back to the 0 and to the 1. So we do that for this guy and we do that for this guy. Because then if we explode this one, each branch is still one complete curve. Okay, but we will have duplicate points. Let's also clean duplicate points. We don't want duplicate points. So this reduces the amount of numbers. So here we have 127 points and here we have 132 points. And we want the ones, everything that remains is a true and everything that goes out is a false. So we want to use that pattern and also apply it on our tangent. Our tangent is a vector, which we're going to use later. To show you guys this, let's bring in a point list and put this to 1. So this is what happened before. Here we have 2 points basically. So I think we have 28 and 29 here. Now we only have 1 point here, which is 27. So that is what we're doing at this point. Okay, now we can play around with these points. So we're gonna put a brep closest point. Let's bring in the box. Yeah, so we're gonna bring in a brep closest point, and we are doing that to get the vector, because we want to play around with the vector. So this one goes into box. My points are going into here, and what we see is happening over here is we get the vector, and that's moving out. But instead of this vector, we want to do like a cross product where this one goes in here and this one goes in there. Let's also bring the points forward. And maybe let's start to play around with this one. So this is what we want actually. So you see everything goes inwards now. It's perfect. So like this is the inner curve. You only see that it's going wrong at these edges, but that is okay. Because what are we doing? So this is one of the things that we're getting. And we are also getting a vector from here, and that is this one. So we get this vector, and we do a cross product based on those two vectors. So far, so good, actually. almost in the corners, but we'll fix that in a moment. Later on, we need to use like a deform curve because we have like a component here or here, and it's called deform points. Yes. And we need to put this into here. The motion and the points. Well, so the points can go into the points because we want to manipulate this curve. And here we're going to put the points, and now we can give to a vector to those points to manipulate all those points at once. That's what we're doing at the moment. So if we apply this one to it, you see what's happening here. So it creates this offset based on this vector, only once again in the corner it's not going well. We will to fix that in a moment. So but the first thing that we want to do, we want to control like how much the offset is. So that's the first thing that we want to do. So let's create a list length. Let's flatten this. This gives me 132. This is correct. Ah, no, we need to do that from this one actually. Yeah, 127. Let's make a range out of this. Remember that as you do a range, always do, sorry, we need to put that into the steps. Always put the x minus 1 because 127, we want to have 127 points out of it. Okay. So now we're going to bring in a RichedGraphMapper. You can also use a normal graph mapper, but I like to use this one. And let's create one that goes from 1 till 4, I would say. Let's construct this domain. No. Yeah, let's construct this domain. It goes from 1 till 4. Nice. And we put that into here. So let's do 5 points, right? So we can play around with our curve here. If you don't like the NURBS curve, you can also use a polyline. That's perfectly fine. So basically this is a bit like the value that we give to the overall curve, the complete curve in that sense. So maybe actually let's do one with 6 points. So that gives us a bit more control to it. Yeah. And to make it even more interesting, let's put a graph mapper behind it and use this one. It's always an interesting form. Okay. Perfect. We need to create another domain because we're gonna remap these numbers. Yeah, so let's put a remap. Also bring a bound. So that's the minimum and the maximum. So we put this. And then here, suddenly we have a new one, and that goes in here. Yeah. And here now we get interesting numbers. What is it doing? This one can go a bit more, maybe to, no, okay. This one can go from 1 till 6, and same for the other one. Yeah. Yeah, and maybe this one can go a bit more like this. Let's put the spikes a bit higher. Then we get interesting numbers behind it. Yeah, because then we can put this one into here. Because this is basically the length. We do see that the branching is not going well at the moment. So we have to unflatten. And we can use this guide actually. Let's move everything a little bit up. And unflatten with this as guide. And then bring it into here. So you see what's happening here, right? So we can control this. With the domain, we can say like how far it should go. Let's put it a bit like this. Fine. No, it's not very big at the moment. I think this one needs to go to 4. Can this only go to 4? Yeah. Okay, and this should be a bit maybe like this. I think I'm quite satisfied with it. Maybe with this system, this can be a troublesome point over here. Let's crank this up one more higher. But as we know, what we need to fix now is these corners, because these corners are not really working well at the moment. So how can we fix them? Well, we're gonna take our points, we're gonna take these points over here. What we're also gonna do is we're gonna bring in the box. we're gonna destroy the box. What we just want to have, the vertical curves. Right, so if I destroy this box, I will get like 12 curves out of it. And if I check the vector of these curves, because it automatically creates a vector in the direction of the curve, we want this vector to be either 1 or -1, meaning it either face up or it will face down. And I'm talking here about the Z, by the way. And so we're gonna say like this one either equals 1. I see 1 is the way to go actually. We can also say or also equals -1, but in this case it's not gonna matter anymore. Yeah, so we're gonna call, and if we do that, then we end up with the vertical curves. That's exactly what we want. So then we're gonna check curve closest point, right? So this one we want to graph at the moment because we want to see for each curve if there's a point nearby. So these are my curves and these are all the points. And if these points, because it attracts to here, so if the distance is smaller than 0, 0, 1, I want to call it. So let's get this curvature list, and it gives me these points, which is correct. Yeah. But since we're not that much interested in the points itself, to be honest, we're more interested in the index of it, right? So how can we do that? We're just gonna use here list length. Yeah. And then we're gonna do a series. Yeah, so we're gonna do a series, and we just want to know like which indexes are the ones in the corners. Yeah, okay, so we have 5 corner points. Is that correct? Actually, if we just do this, it should give us like 5 points. Yeah, so here, 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 and here, and here. Yeah, 5 points. Okay, so what we're gonna do is we're gonna +1 this, because we're gonna replace the vector with the one next to it. Because as you can see over here, no, not this one, but this one. And so this one we want to replace, and we want to replace it with this one or this one. So that is why we're gonna do a multiplication on top of the index. So we're just gonna make this 1. Exactly. And we're gonna replace items. And which items are we gonna replace? These items we're gonna replace. Yeah, so what we're gonna do, we're gonna replace them. So which one are we gonna replace? We're gonna replace this one, because this is the one that I'm using further down here in the pointee form. So we're gonna bring this one in. We know that we need to change these indexes, right? These ones we need to change. And we need to change them . Yes, and these are we're gonna deconstruct, and we get like a Z value, and we're gonna round this value to make it easier, because it gives us a 1 or a -1. And we're gonna give that value to the Z. And that's the ones that we are gonna replace. So if we do that, we're gonna replace this. And now the only thing that we need to change is this guy. So again, so we need to unflatten, basically same as we did over here. That means we need to bring it back into the correct data branch. And then we're gonna replace, let's give it even a bit more space. And then we're gonna replace this one. And now, voila, we have it working. And so what we did is we took the vector from either one of the neighbors and replaced it. Because as we all saw, like this vector was giving issues on these corner ones. And so that is what we did at the moment. And here we can fully play around with how the curve should behave. So we have a bit more, let's make this a bit bigger, and also this a bit bigger. Yeah, this looks a bit more neat. Okay, so we have done this only for one side, of course. We need to do that for the other side as well. which is more easy than you think. The only thing that we need to do here is we need to negative these values here. So let's negative these values. You see that it duplicates it on the other side, but of course, if we're gonna play around here, we can create our own effect here. So now we have done that for both of those curves. Yeah, so let's play a bit around. Also here, you can make this smaller and bigger on this side. And in the end, you can of course also change your, right? So here we put this one and here we put the ISO curve. Maybe let's also change this, save current viewpoint. Yes. Maybe we're gonna just put this one a bit higher, because I like it here to reach it. I want this bottom curve to be a bit more, yeah. I think I'm quite satisfied with it. Yeah. So there's one tiny mistake that I noticed. I started to play a bit more around with the curve, and then suddenly this is happening. Right? So this happens when the curve is here all the way at the bottom. So when it is like hitting the bottom of the elevation plane. So in order to fix that, we can go to the BREP closest point. And instead of the box, we just take like the vertical surfaces. Because what's happening now is what you can see, it creates this very weird vector at the moment. And that happens is because it snaps on the bottom surface, basically the ground surface, which we don't want to happen. So the fix here is we bring this guy in and we just take the sides. We join them because we still just want to work with one BREP. And once we link that one, it will work fine. So actually here it's going well, but we need to do this similarly also for the upper curve. So let's replace this box with the new box that we created, and then it's going well. Perfect. So we have two curves here now. Let's bring them together. And let's call this one façade curves. The next step that we're gonna do is we're gonna take the façade curves. We bring them here. Let's hide all this. Let's also hide all this. Let's go back to the ISO view. And we're gonna take this one as well, the meshed façade. Because the next step what we're gonna do is we have like this mesh façade. So let's make it tangible. Wait. Yes. And we're gonna align this curve that we created. We're gonna align it on the underlaying grid. Meaning that here it will snap to the grid of the mesh. It will do so everywhere. Like that's our next step that we're gonna do. So like let's maybe hide all this. And let's start with the façade curve. Yeah, so let's bring the curves in here. So there should be 4 curves in there. Yeah. Let's take the first curves and no, actually we can just evaluate curve. And we want to have the beginning part of the curve. Well, it is good. No, it's good. We should reparameterize it because 0 will work. But if you now make this 1, it goes to the other end. It doesn't do that if you don't reparameterize it. So let's do it. We start with a 0. Yes, very nice. So we're gonna make a Bezier curve. Because basically we want to have like the end, right? We have something that goes like this. So let's put these in the A. We can do similarly, we can do for the T. T is always a tangent. So first we're gonna increase the tangent. Let's make an amplitude and let's increase it with 4 in comparison to the 1, which is a standard value. No, this should actually go in here. Yeah. Perfect. Let's make it negative. To go the other way, it's quite simple. Yeah. And it does so at both ends. Yeah, it also does it here. Perfect. Now let's divide this curve into 3 points, I would say. Yeah, it will create 4. So 1, 2, 3 segments. That's how you should read it. And let's make a polyline out of this. And perfect. This is what I want. So I'm gonna do the exact same. And if I make this a 1, it will do so on this end. But here we need to replace the negative. So here we're just gonna remove it. And so far, so good. Yeah, so now we have a closed polyline. Because this was closed yet. We just had the horizontal beams, let's say, but now we can close it. We're gonna bring all this together. And we can do that with like a nice merge component. We do need to simplify. And also this one simplify. Not graphed, simplify. And also this one simplify. Because it should keep its data branch structure. Yeah, okay, so I have 4 curves now. And let's create one for this as well. Yeah, okay. Okay, now let's join the curves and make it into, I will get like 2 curves then. Yeah. So I have like full curves now. So this is one, now this is the other. Now we're gonna explode this. Yeah, so we get all the points. And we're gonna graph them. Yes, and this is where the mesh facade comes into play. Because I want to extract all the vertices from the meshed facade. So let's hide this for a bit. Let's bring this one in. Let's flatten this. Yeah, is it flattened? And what if you put a disjoint mesh? Is that needed? No, the opposite actually. Okay, we can go into Weaverbird. We have this nice component here, which is called Weaverbird vertices component. It basically takes out all the vertices. So there's a lot of vertices now. Let's also hide this. So a lot of points. Right, and now we're gonna do closest points. Because now I want to have all these points of the curve. I want to bring it towards the closest point possible. So it will make this one, and this one goes to there, and this one goes to there, and so on. It will do that for the complete curve. So my search space, this is per point, and this is grafted, so it does for every point individually. And wait, I need to do a mesh join because this needs to be like one full mesh, one mesh, yeah. And then this, and then I suppose when I take this one and bring this one in, let's check it out. Did it work out? Because this was our initial curve, and you see that it automatically creates these new points that are as close as possible, because this was what it was previously was. I should hide this. Yeah, and it made it into that. So that's perfect. So I'm gonna do the same over here. Yeah, so because these are only the side points without the end. Yeah. Okay. I want to bring it back into like 4. Yeah, so shift path. Yeah, so I'm gonna do a similar story here. So I just take like all the points. Yes. And then I'm gonna bring that back into 4 branches. So every curve its own branch. Because we need to have this later on, and this works fine. Yes. Now let's keep it neat. Let's call this facade points. Yes. Okay, let's shift path these ones, and let's make a polyline out of this. This will give me like 2 polylines. I might need to remove duplicates because there might be some overlap here and there, which is okay. We're just gonna filter them out, and you can see that it is working now. So it goes from 248 points to 244 points, meaning there were like 4 points overlapping. We're gonna do a similar story to this one. So here I will have 4 points, and here I will have, sorry, 4 curves, and here I have 2 curves. Yeah, let's maybe close this one. Let's hide also all this. Maybe this one as well. So here now I want to see like the endpoints of these guys. Yeah, we can actually merge them. And then we do like a curve closest point. Curve closest point. Yeah, and these are my points. They can go in here. And one of them needs to be flattened, and I think it's this guy. Yeah. So I'm gonna get a lot of... Yeah, so whenever this is 0, I want to get the parameter. Yeah. Here I have 4, and here I have this. Yeah, and so with these parameters, with t, I want to use like a shatter component, because we want to cut this curve. And then it will cut it so. So if I'm gonna take the first one, this is good. So let's take this and this one. Yeah. You need to put multi-line data. So first we need to sort them. That makes it easier. So let's sort them. Yeah, now I have like all the ends out of them. That's perfect. We also want to isolate them. Let's close the curve. Yeah. Is it closing the curve everywhere? Yeah. Let's make a surface out of it. This is perfect. Let's shift them to bring them back into 2 branches. Basically, in the end, I want to have everything back to like 2 branches because we have 2 curves at the moment. And let's call this end pieces. And we need them later for setting up. Okay, so we can go to the next step. So we have our end pieces, and we also have our facade points, which are now aligned to the underlaying grid. Exactly what we want.